Busy setting things up. All right. All right. I think that's good. I think we're good. I think we can start. It claims an ad is running, but my timer is not showing up, which is a bit annoying. Yeah, it claims that we have an ad and it's going to last for 50 seconds. Oh. Decrease the audio a little bit so that it's not super loud. All right, I think this is good. I think this is good. Let's go ahead and just start. 20 seconds remaining. All right, yeah, let's begin. All right, how's it going? I fixed up the avatar a lot. He's still very bouncy. I think I need to fix how the talking works. It's very quick. I like how fast the transition is. I think it might be a bit too fast. I think it might be a bit too fast. Oh well. Today is the 4th of July. So naturally, we're going to have to wear an American flag shirt. Since I'm American. Have to celebrate the 4th of July. I wish I had drawn fireworks. Oh, yeah. I wish I had drew fireworks, but oh well. Anyway, let's get to programming. So last time what we were doing was we were going through learning Zig. We were doing it in a very roundabout, silly way. What we were doing was we were going through Boot.Dev, their C, refreshing up on C, as you can see right here. And I was transferring, not transferring, but I was taking the knowledge that we have here on Boot.Dev that is in C++, and then translating it to Zig and running it that way. And it's been kind of working, but also we've been spending an awful lot of time just troubleshooting. But it is what it is. I don't think there's any other sources out there for learning Zig that's set up like this. If there are, tell me. For now, we're just going to have to continue doing this. I'm fine with that, though. So let's continue. So let's see here. So last time we were stuck here trying to figure out what the major problem was. If you see here in this example, we have C, or in our C code, we're printing initializers, max threads, all this other information. And then finally, we're running this in the main function. And the test was to write our own function called max sneakland memory. So the idea was that we would generate this. And yeah, the idea was that we would generate this. And from there, we would then do what we need to do. And for the longest time, we're having a lot of trouble figuring out what was the problem. And I ended up getting it working afterwards. So let's go into here. Here we go. Again, it helped learn a lot, actually, figuring these things out. So First thing, we need to set the units afterwards. We need to make sure we always have our semicolons at the end. Main function can only output U8. So apparently, that was a bit of an error on my part. I did not understand that the main function's output is actually held in very high regards. Like, this is very sacred stuff right here. So if you do a return of anything that's not a 0 or -1, it's going to throw an error. So you can't do what it was originally because I originally thought that it would just be something simple. So let's head on down here and I can show you what I mean. So if I set this to something like 42, it's the number of life, the life universe and everything. I figured if I just simply have it like that, then everything would run perfectly fine. But let's go ahead and run this. So zig build run is going to throw an error. Okay, it's going to eventually throw an error. Okay, it's taking a very long time to throw an error. Okay, I think it's not going to throw an error. So while that's busy, oh come on, this isn't rocket science. Did I just crash it? But all right. While that's running, oh perfect, finally. See, there we go, perfect. Error. Right here, we had a failure. And then if you look, it says the error is following the marker exited with code 1. Run transitive, failed to learn, or failed to run this. Then if you go digging, where is it? Here it is, right here. Exited path with code 42. So apparently that means something. I did not know that. So let's go back into our file. I remember that someone told me that there was a way to run the, I think it was colon control. I forgot. I have poo for brains. I forgot what it was. But anyway. So if we go back into here, let's head on down. Now let's change this to what it's supposed to be, 0. Now we'll write and quit. We'll rerun. And there you go. It runs perfectly fine. So yeah, that is apparently something we need to be very cognitive of. At least for the main function. The output, it can only be a U8. It can't be anything else. And those codes are very important. It has to be a 0 or a -1 or something in those regards. It can't be some weird goofy number because we felt like it. Which is, yeah, a bit sad. Anyway. So let's see here. So another thing, as I mentioned, we need semicolons at the end. For things like numbers, we are perfectly fine. But if we're going to output for instance, a string, we need to put an S in here. Since none of these are S's, we don't have to worry about it. Units, these have to equal. Which is, yeah, I mean, it is a very duh thing, but when you're coming away from Python, where you can effectively pretend type doesn't exist, these things, you have to kind of relearn to be very cognitive of these. But with that in mind, as you can see, we have done this and it all works. Now, because of this, I've actually started kind of making a little track of what this is. So I don't know if I can show you because it's on a I can't show you. It's on a completely different system and I can't really connect it. At least not to the output. But what I've been doing is as we go through, I've been generating what the question should be and then what the answer is, so that later down the road I have a reference. Let's see, where's that file? Story of my always missing out on my where did I put the file? Here it is, right here. Okay. Yeah, okay, so let's see here. Maybe I can transfer it over. Oh, it doesn't matter. It doesn't matter. The main thing is I have my own files that I'm tracking, and as we go through Boot.Dev, I'm slowly converting these to into a zig format. So once we get through to the very end, yeah, I'll have a whole bunch of these questions turned into zig ones. I don't know what it means when it comes to how it's going to affect the lesson, but at least the questions are easy to mess with. Anyway, let's go. Next question. Voids. Hey, function 95. How's it going? Let's see here. We're learning Zig. And trying to refresh my memory when it comes to NeoVim. Good to hear. Good to hear. All right, let's see here. So this is the next lesson for C++. Actually, we don't need to quit right now. So let's see here. What's the question? In C, there's a specific type of function signatures, void. There are two primary ways of using void. To explicitly state that the function takes no arguments, when a function doesn't return anything at all. It's important to note that void in C is not like none in Python. It's not a value that can be assigned to a variable. It is just a way to say that a function doesn't return anything or doesn't take any arguments. I kind of always thought that Python's none was the same as a void, but apparently apparently that's not the case. Does Python have does it have a void type situation? I don't think so. I'm still surprised that Python doesn't have pointers. Anyway. So which of these is not valid? Well, because this is all C, let's see here. We can figure this out. So that's valid because we're saying X is a void. This is, let's see here, void print hello. That's a void function. So that should be valid as well. And then this one right here is also a function, so that should be valid. Int get number void. Okay, one moment. They're all looking pretty valid. Oh wait, I think they're all looking pretty valid to me, actually. Because this is how we set it. Oh, actually, I think it's 1. Because it's 1. Figured out. Okay. Yeah, because they said that void is... This is what I'm talking about. Void means that it's a nothing. You can't assign nothing to a value to it. So, yeah. Number 1 is wrong. Let's see, did I write up the question in a Zig format? Oh, I did. Let's see here. Yeah, I actually did write it up it is in the format earlier. So let me show you what I put down for the Zig rendition. Oh. I think I'm going to need a U. There we go. This is what I did when I was converting it. And so because of how they do in Zig, it's a bit different. So here you would have void. This is the same, void x equals none, then a public function, then the void is at the end, and then here a void void, which is kind of funny. It's kind of funny when you see it look like this. And then lastly, pub get function number void u8. So yeah, it's number one that's not valid. All right. So let's continue with the code. But actually, we'll have to eventually go through and start looking because, you know, there's Zig, there's Rust, there's C#. Like there's a many different versions of C out there, and I wonder what the general difference is between them. I guess you could say what is their mode operatum, or you know, what they choose to, how they choose to, or what their goals are when it comes to a programming language. Oh, unit tests. Okay, let's see here. Our unit tests. Up to this point, we've been checking the standard output of your code against our expected outputs. Now that you're familiar with functions, most of the lessons will be graded using unit tests. In particular, you'll be using the MUnit testing framework. It's a simple, lightweight testing framework for C. Oh, I wonder if we have a Zig variant of this. Let's see here. At Boot.Dev, the run button is for debugging, and submit button mimics the idea of publishing your code for production use. You should be debugging your code using the run button. You should be adding printf statements to your code to make sure that it's doing what you think it's doing at different points in the code. Write a line to calculate a value, printf the value, run the code. Did it print what you expected? If not, fix it, repeat. You'll never lose XP or be penalized on the boot. Oh yeah, because we're not we're not logged in, so we're not going to be able to gain experience doing this. I wouldn't mind doing that, but yeah, I have no money. Maybe when I eventually start earning an income. Let's see here. Take a look at the main C. You'll notice that it's read-only. Open exercises. Write the getAverage function in exercise C based on the function prototypes expected in CH. Oh. Where is this then? Actually, let's continue reading first. Okay. Take a look at the C main. You'll notice that it's read-only. You can't change the tests. That would make it too easy to cheat. Includes an exercise.h at the top. Open H and you'll see the function prototype signature of the function you'll need to write in C. .c files contain the implementation, C code. H files are headers that contain the function prototypes. To import code from another file, you include the .h file. Exercise.c includes exercise.h. Main.c includes exercise.h. This allows main.c to call functions implemented in exercise.c. All right. Let's see here. Does Zig have that format? Let's see here. Oh. We have main.zig and root.zig. We have zig out and then zig cache. Oh, here we go. Oh. I have a feeling that this is indeed just cache. Yeah, this is just all cache. I have a feeling Zig doesn't... I have a feeling that Zig doesn't do anything with header files. We might have to go check that out real quick. All right, to our handy, here we go, to the documentation. Currently Zig is at 0.16, all right. Let's see here. Header. Here we go. C pointers. This type is to be avoided whenever possible. The only valid reason for using a C pointer is in the auto-generated code from translating C code. When importing C header files, it is ambiguous whether pointers should be translated as single item pointers, *T, or main item pointers, brackets, *T. C pointers are a compromise so that Zig can utilize translated header files directly. All right. But does Zig use header files? Here we go. Let's see. This header is generated by Zig. Yes, apparently it does use header files. So include... Oh, that is standard C, though. Right here. And here's what the Zig looks like. So we have build function, void, da-da-da-da. Okay, we want to math test.h. All right. Yeah, we just want to add 42 and 1337. That's what that is. So here should be the const lib add library, linkage dynamic, name is math test, the root module is b create module. Why is it like that? Oh, okay then. Why is it like this? I see the version, so this, I guess this is a way to do version control. This is in their build. Hey, Giovanni, how's it going? Oh, it's fine. You shouldn't worry about it. Go ahead and stream yourself coding. I've always figured that this is the best way to force myself to actually learn something. It's always funner to learn with others, I guess is a good way to think about it. So let's see. Right now I'm trying to figure out about Zig and headers, because apparently they should... Because apparently Zig doesn't actually use headers. This is a header generated by Zig from base64. Yeah, this is what it's test.c. Here's base64 Zig. And then this is how they would set it up. Oh, if you're streaming while I'm on, I'll be sure to stop on by and say hi. Okay, oh yes, I do have Boot.Dev open right here. Actually, this is the first time I'm using it, so I don't really know how good or bad it is. Right now, it seems to be. I'm enjoying it, even though I'm kind of I'm doing the free version. So with Boot.Dev, all of the lessons are freely available. However, you don't get any of the feedback. So that means that if I mess up, I have to go through to figure out why it's messed up. There's no way to use their system to figure, for them to give me hints. But since all of the lessons are freely available, then it's quite a good repository for knowledge. Time to create open boots. Yeah, right now I'm trying to see if... Okay, why don't we... Okay, I'm going to hop over to... Let's just open up a new one here. Does Zig use header files? I have a feeling it does not use header files. How are headers used in Zig? Oh, perfect. How are headers used in Zig? Let's see, I haven't used Zig much. I got stuck early not understanding the standard library. How does headers work in Zig? I imagine if you have two Zig files, I can call a function in the other without a header. I'll include the C+ code. Let's see here. Oh, okay. Thank you. Go away. I imagine... Let's see here. I imagine if I have two Zig files, I can call a function in the other one. Yeah, that's obvious. If I include a C or C++ header, can I call that? Yes. Oh, chapter 4. Hey, chapter 4. I think this might be what we want. In-memory layouts, by defining the rules and breaking the ABI is said to be stable, and this can be used to, for example, reliably link together multiple libraries, executables, and objects which were compiled separately. Zig natively supports C ABIs for extern things, which C ABI is used depending on the target you are compiling. This allows for nearly seamless interpolation with code that is not written in Zig. The usage of C ABIs is standard amongst programming languages. So apparently, at least we know that Zig can use C headers. All right, so with that in mind, can I grab the files here? Oh, this is something else. Oh, here it is right here. Aha, perfect. So here is our main function right here. Here is the exercise. And this is exercise C. Got it. Okay. All right. Let's go ahead and start doing let's do what we need to do first. We need to start translating. Well, I think Zig has it built. This is my second day learning Zig. So I can't really say, but I think C has it implemented in, so I can start using C API. At least that's from what my current understanding is. All right, so NeoVim. Oh. All right, so let's see here. We want to go to 25DD. Aha, okay. Let's go ahead and put our... Oh. Let's copy this. Okay, let's put that here. Now then, let's start setting this thing up for us. This happens to be our main code. So here's the main. So first things first. Pub function. And then this is going to be a U8 because we figured out the wrong way that needs to be a U8. All right, so then here we have M unit tests. And then here are our 4 tests, and then so yeah, that's our function 1. This is function 2. And then up here are all our unit tests. So let's go ahead and convert this const. We'll call it exercise for now. Actually, I wonder if this will work. I have a strong suspicion that the answer is no. I have a strong, yeah, of course. Oh yeah, I forgot to put the let's see here. How would we go about translating this? Okay, then let's see. I guess the first things first, let's get back over here and see how does it. Let's see here. How does Zig handle how does where's that word again? I just forgot it. Hey, MKF Gaming. How's it going? Let's see here. Unit test. There we go. This is my brain is. Sadly, my brain has trouble. Let's see here. How does Zig unit tests? How is Zig doing unit tests? Okay then, so const expect std testing expect test. Oh, it's test. Brain stopping, brain. Exactly. Actually, that's something that's kind of funny. There is a so to kind of do a quick tangent, there's this weird phenomenon with the brain where when you're trying to hyper-focus on a particular topic, what ends up happening is your brain will shut down any other firing around that particular region. And by doing that, it will effectively inhibit your ability to remember, especially if the topic is very close to what you're trying to think of. This is kind of a way to make it easier for at least for your brain's idea. The way your brain is computing, it's to try and help you focus, but it just ends up making you not be able to remember a tangential topic. It's so yeah, if you're ever sitting there trying to talk to somebody and then you go, oh, what is that thing? I can't remember. It's on the tip of my tongue. You know, like it's just this little itch in my brain I just can't get to. It's because your brain is preventing you. It's very weird. The brain is very fun. Yeah, the brain is quite fun. So I guess, so unit tests are test. Oh yeah, I remember messing with test earlier. So here we go. So we'll be function. Here we are. And then test memory leak. And then const allocator. Here we're running the, and then here, I see. All right, I see. So what's going on is our unit tests are basically just test. We give it a name, and we then proceed to run it. Here we're running the function, or here we're setting up our allocator, and then here we are running our actual function. So with that in mind, that means all the unit tests that they set up here which is munit case. We just need to change all these to test. Let's see here. What? Oh, I see, I see. Yeah. I know what you mean. Sometimes sometimes I just want to rush to try and get the thing working, but I've usually sometimes from my experience with doing research, sometimes you need to just slow down and try and think step by step. Otherwise, you're going to run into a lot of problems. There's a very fun quote that I can let me see if I can not butcher it. Let's see, the quote. The way the quote went is, I saved 3 days in the or let's see here. Actually, I'm already butchering it. Okay. Let's see here. 3 weeks in the lab saved me 3 days in the library. There's the quote. I do not know who said this, but it is a very truthful quote that I have sadly learned many a times when I was doing research. So I'm trying to avoid doing this by trying to more methodically read through the materials and learn exactly what's going on. But because we are going to do test right here, this is how we're doing our unit tests. That means all of these are going to be tests. Now the question is we put it afterwards. All right. So actually, I think it doesn't really matter where it belongs. But what I do know is that we're going to now change these. All right, so let's see here. Actually, we probably should check the structure of the data too. Oh, hey, thanks for the follow, MFK Gaming. Thanks for the follow. All right, let's see. Let's get back to Boot.Dev. Here we go. So let's see. We have exercise.h. We have exercise.c. And then here we have run. And I believe these are the run and submit are just for these 2 buttons here. So ideally, what's this going to happen is when we hit submit, it's going to run these 2. If we hit run, it's going to run these 2. I noticed that the surprisingly, there's not much similarity going on. This is the assert functions. Assert double equals. And here are the functions we're going to be testing. So test get average. So here are the functions we're going to be testing. All right. I guess let's just start converting these files. Or let's start just changing the code up so that it's more palatable to Zig. So with that in mind, let's go back here to our example. I'm going to shrink this a little bit so that I have a bit more space. There we go. All right then. So first things first. So let's see here. So test. And this will be the get average. And then from here, const result, and this is a float, so U32 or F32. It was float. The floats were F32, if I remember. And then this happens to be equal to get average. One second. Let me see if there's other examples of test. Right here. Oh. It should be that, yes. All right. All right. Thank you. Yeah, I'm just trying to make sure that I'm doing things, or I'm not, I'm trying to make sure that things are going correct. Okay, then. So the next is going to be, actually, where is this function right here? Let's see here. Oh, it must be here, the mu. I get it. Okay, that explains a lot. Okay, it's because we're including the this right here. The munit.h, which happens to have not been given to us, so can we find that? Hey, here we go. Okay. Okay, well, let's see here. Double equal. Ah, here we go. All right, so... Oh yeah, so these are all just a bunch of assert functions, aren't they? Assert double equal, da-da, precision. And then we run the code right there. Immunassert, okay. Yeah, it looks like it's just... Oh, that means there's a... All right. I'm just thinking, because that means that effectively we could... Maybe this might be an opportunity to try and bring in the seed that we were just looking at. Particularly this code right here. The header code, where are you, header code? Okay, where's the header code that we were just looking at? That's the testing. I think it was this. Was it this one? Yeah, maybe this one. Yeah, it was this one. Okay. All right. Okay, then. Let's see. So this is where we get they're bringing in the library. So in this case, they're bringing in math_test.zig. Here's the header that they set up for C. This header is generated by Zig. So there's the math_test.h. There's our main function. So const lib equals add library. Linkage is dynamic. The name is math test. There you go, math test. The root module is this. Okay. I'm going to go see if I can find another example as well. It always helps to see as many examples as possible. Let's see here. Zig, header. Not sig header generators. Handling. Let's see here. Well, yeah, I mean, yeah, I like doing it that way when it's in the... I like that a lot right here, but I'm trying to see how to deal with headers. See, headers. When you're choosing this strategy, you'll need to use a translate C tool. So translate the C headers files that you want to use into Zig code. For example, suppose you want to use fopen, C function from the stdio.h C header file. We can translate it through the bash command below. Zig translate C that. Oh, we should try this. Oh, let's try that. Let's try this. Maybe we can do a translate of this unit's munit h. Okay, let's see, munit.h. Let's quit. Okay then, so Zig. Let's see here. We'll right here. All right then. So we'll want to do a Zig translate. C. I need to get that file. Okay. I wonder if that's already where it's located. Let's see here. Fat fingers. And then we'll go to include. Oh, I think it might be in here. We're looking for unit H, if I recall. Munit H, right? Yes, munit H. Let's go down to the M, or up to the M's. There's menu, mcheck, math. I do not see munit H. Yeah, munit H is not here. All right then. Okay, if that's the case, then what we're going to do is we'll have to download it. Hey, munit, how are you doing? Don't mind me. We're just going to grab you. Hey, it's a unit testing framework. Fun. Apparently we just need to clone it. All right. Why don't we clone it in the Zig projects folder? Well, this isn't exactly a Zig project. Let's see. Hey, yeah, why don't we put it somewhere here? Why don't we make a folder? We'll call this the include code, or includes. All right, git clone. There we go. So there we go. We have our M unit now. All right, nice. Oh, I see the .h file, which is exactly what we need. So let's get back over here to try and translate. So all we need to do is go to here. Why don't we all right, so why don't we put let's see, we'll go into here, translate it. Zig translate C. Actually, if this works, actually, you know, if this works, maybe what I should do is I should start copying and pasting all of the, well, technically I should do it by hand myself right now. That way I can learn the syntax. And then eventually, once I become proficient enough that I start remembering these things, then I could use this translate. Because if I could just translate all of the files, then I wouldn't have to do it myself. But, as I said, I won't learn it if I do that. So for now, let's go ahead and yeah, the brain is a very strange annoyance. Oh, actually, I think let's see here. How long have I been streaming? I've been streaming for about an hour. What we can do is I'm gonna, once we finish solving this, we can hop over to In a Nutshell, and we can do a quick watch of one of their videos, because they came out with a video like 2 weeks ago. Okay, let me okay then. Let me go over here so I can show you. In a nutshell. Processed food won't kill. I guess that must be new. I will have to watch that. Anyway. Video. There it is right here. This video right here, 2 weeks old. This video, it is it explains how the brain works in a very nice manner. I would highly recommend watching it. It's only 13 minutes long. The visuals are very nice. It is both extremely dense in information, and not enough information is presented as well. They try to simplify it enough so that you could understand it, which is quite nice. But boy, when you know this material and you're listening, you quickly go, that's a simplification right there. But yeah, I would highly recommend watching that. It's very fun. We'll watch it after we get this problem solved. But for now, let's see here. We want to translate this. So it is, I agree. That it is one of the great channels. I enjoy all the stuff that they put. I even bought their game. Oh, okay. I received the game as a gift, but they have a game on Steam called Starbirds, I've been having so much fun with that game. Oh, on my second channel, I have already racked up a couple. I've racked up a bit of time on that game. My goal is to get into the top 10. I will have to play a bit more of that later, but yeah, it's such a fun game. I'm hoping that they'll release more content for it in a hasty manner. So by trade, I am a research scientist who specialized in data analysis and data analytics. Yeah, that's by trade. I ended up doing a lot of, let's see here. Okay. So I ended up doing a lot of research in regards to things like regeneration, particularly in the eye and later in the brain. And then I did that for, like 15 years. And then after that, I ended up going into industry, and because I have a lot of knowledge in data analytics, and I ended up working there a lot, doing data processing, data engineering, the whole shebang. And then due to the rise of AI, I've been having lots of fun with this avatar. I have lots of outfits I'm working on for him. But yeah, due to the rise of AI, I currently in between jobs. I think I might have found another job recently. I'm busy going through the confirmation of credentials, so hopefully I'll be able to start working again. But for now, yeah. This is one reason why I'm doing a lot of self-learning right now and having fun programming. You're in the same boat? Yeah, the market is so tough right now. It is a very tough market. And it doesn't help that there's an awful lot of, for lack of a better word, morons who have no clue about any of the stuff that's going on. So they're making these brain-dead decisions. And all I can say is I'm going to enjoy watching these places make the dumbest decisions they've ever made possible. For instance, apparently Facebook recently they just found out that they are wasting so much money. Yeah. I'm in the very, that sadly is the exact same boat I am in. I've sent out so many applications and so few interviews, and usually they either reject or they go, we're sorry, we can't fill the position at this time. It's like, it is so annoying, so annoying. All right, let's see. We want to go home. And then this was, why do we end up like that? I think that there's a couple reasons why. There's a couple of reasons why. One of the reasons why I think this has happened is because there's an awful lot of upper management who thinks that the latest boom in AI will replace a lot of low-level work. So a lot of the entry-level positions and even a lot of the middle positions. For instance, I would say that I'm probably in the middle. I'm not a I'm not these elite programmers, but I'm not an amateur I'm not an amateur. I'm in the middle. And a lot of these lower positions and a lot of these middle positions are being let go because they think that one senior dev with 4 AI will cover it. So it's just a bunch of cost cut. There's that one reason. It's a bunch of cost cutting to try and earn an extra dollar for. Yeah, the second problem that I see is that there's an awful lot. This second point is a bit difficult to exactly talk about because. Okay, let's try and go point by point, and I explain it as clearly as I can. There's an awful lot of people in upper management who overvalue their worth and thus pay themselves that value, even though they're not worth that much. I'm talking about these people who go, oh, I'm a CEO. I'm going to pay myself $5 million because I'm a CEO, when the value that they give isn't even $200,000. And because of that, they keep taking a bigger portion of the pie, which is, the amount of income that the company makes, which means that there's a lot less pie for all of the people who actually get the work done. So that means that you have senior devs, junior devs, the mid devs, all of these people are now getting less to hire new staff, and they're being worked harder in order to cover for the lack of less pie. And it's infuriating where you'll see a company, they will hire a CEO, the CEO will give themselves a raise, and then the company goes bankrupt because they don't have staff to do all of the actual work. And then the brain dead thing is that CEO will move on to another company and do the exact same thing. And it's infuriating to see that. But the reason why it's a bit difficult to talk about is because I understand that if you're a CEO of a company, you are allowed to set the price that you have, or how much money you pay yourself because you put in the hard work to get to that position. But it doesn't change the fact that that's still a point that causes this problem. Let's see here. Oh, let's see here. Yes, you're 100% right. That is 100% right. AI is it's not thinking. This is a complete misunderstanding of the actual technology. And because of that, AI, every time I use AI, it's able to get close to what I want. But then when you start digging in, it's made a whole lot of weird, abnormal, stupid things. And you're like, what are you doing, AI? This is totally inefficient, and you're wasting so much resources doing it this way. So yeah, AI is not going to, it will help people write code faster, but it's not going to improve the quality of the code. In fact, it's just going to make it much worse. Yeah. I have a lot of, because I'm I'm a neurologist and I am also a data analyst. I have a lot of fun ideas about how I would implement AI to try and make it a thinking individual. But the problem is that the computational power needed is just like ludicrously high that it becomes there's going to have to be something to give in order to get to that energy level needed. I mean, I did think about this is where you're blending neurology with computer science, because a brain, let me load up GIMP so I can draw a bit, to try and explain what I'm talking about. Oh yeah, and it's the 4th of July. I need to, let's see here, it's the 4th of July. I need to get back to my, my casual t-shirt. All right, here we go. Here's GIMP. Let's create a new picture. There we go. All right then. So to try and briefly explain how a brain works and how an AI works. So let's go down. There we go. Oh, not 13. 13 is too big. I guess 4 will work. All right then. So the way an AI works is you'll have a node or multiple nodes. This will then connect to many other nodes. This is the very common network that everybody always sees, whenever they're talking about neural networks. And then this will go through another layer, yada, 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 where these are all connected. And then finally it gets reduced, and then you get your final output, something like this. So this is how it works. And this is largely how, this is largely how even the LLM works, the language models. What happens is you'll put in a phrase. So I'll say, I like. So something like this. And then we want a blank. And then based off of the training data, when you start going through here, it will adjust all of the weights. And then the final outcome will pick the most probable word. In this case, it would be raccoons. So yeah, if I trained a model on my history, it would be I like raccoons would be the output. On the internet, it would probably be cats, because cats are super popular, or dogs. Like dogs are, for some reason, I keep getting dog videos. Anyway. Now, how the brain works is something very similar. In fact, this is the reason why it was called a neural network to begin with, is because the people who created it, this setup, they were trying to mimic how the brain functions. So what you do is you'll take a neuron. So here's our neuron. And this will connect to a neuron as well. And then this will also connect to another neuron. So if you notice, it's kind of looking similar to this. However, you have many neurons. So let's go ahead and just start connecting. And they do the exact same thing. But they don't just connect to their, the next layer. This layer can communicate with the other layers downstream of it as well. So it can do something a lot like this. So these guys can just connect. And then it gets even crazier, because these guys will have, these axons can actually branch off, and they'll go connect to another one as well, like this. So effectively, what you can end up having is these. So let's actually draw this properly, because it's not technically multiple branches. It's one branch, but it's one axon. But this also happens to, like this, kind of like that. And because of this, what ends up happening is these neurons can all intercommunicate with each other, and they'll kind of do the exact same thing as this does. So the different firing patterns, well, maybe we should go watch the In a Nutshell video. But yeah, all of these will communicate with each other, and then based off of how often you use these connections. This is one reason why I said I'm going to be typing out everything until I start remembering it. Is because if I do it enough times, these connections will become extra strong, and then they will not degrade, because these branches are always forming and retracting in your brain. This is one reason why you'll pick something up and then 5 minutes later absolutely forget it. And that's because these connections were not strong enough. It's through repetition where these connections become more solid and they stick around longer. And these right here, now this is what I was kind of referring to. I think that let's see. Yeah, you're right. And the reason, I was actually about to get to that. And the reason why is because the connections here, let's draw ourselves a little brain. Here we go. Here's our brain. There we go. So here's the brain. All right, here's the frontal cortex. Here's the spinal cord. So here we'll put a spine. Here's the frontal cortex. Back here is the visual cortex. This is the it's the region that Star Fox likes to attack. I forgot what it's called right now, but pretty much what happens is the frontal cortex is involved in processing. So what will happen is you'll have something like the visual cortex light up. Let's change the color. Let's change the color. We'll make it a nice yellow. So what will happen is you'll get some kind of pattern firing in the visual cortex, as well as in other parts of the brain. And then all of this will get processed in the frontal cortex, which will in turn tell it, it'll try and add weight to it, like an understanding of what's going on. So this firing pattern here will cause this type of firing, while a different firing pattern, let's put this in green. So this green firing pattern that happens, it will result in a different area in the brain firing. And the frontal cortex is involved for processing. So if this fires and then this area in the brain fires, it will tell us, oh, this is, I saw a stop sign. It being stop. While if you pick a different, or the other firing pattern, when it fires, it would be something more along the lines of, I saw a bear. I am now lunch. So that's kind of the purpose of the frontal cortex, is to add context to this information. And currently, most AI models, they can't do this. This step does not work. What they do is they will take your question of I like, feed it into a neural network. They will then take that exact same thing and then feed all of this back into the neural network. And that will then further refine what the output will be. It mimics this upper level, they call it L4, I believe. It mimics this L4 layer without actually generating the L4 layer. And it would be very fun if what would happen is as if we took a neural network and started having another neural network control how all of the weighting is going and how the inputs are processed, and try and just build up these layers. If we did that, we might actually get some kind of cognitive AI system. I'm trying to simplify a very complex thing, so, because the brain is very complicated. Totally different thing. Oh, good. Glad I explained it. As I said, we should probably go watch the In a Nutshell video. How about... okay, let's... Oh, okay, yeah. All right. Let me stop the music. All right, let's go... Let's see here. Let me go load up In a Nutshell so we can watch it. Let's see here. One second while I get this set up. Oh. Come on, we want to be a little bit larger, but not that large. There we go. Okay, now let's see if we can, Yes, you're right, yeah. Pattern recognition is super quick in our brain. It is ludicrously fast. Oh, I mean, it is, our brains are they are monsters when it comes to designed to processing. Usually your brain has an idea about something almost immediately when it sees it. It is lightning fast. It takes a few seconds for the processing to come in for us to understand what it is. And it makes sense if you think about it. The reason why that it's set up like this is because if we see something dangerous, like back then when we were cavemen, I should make a caveman avatar or, a caveman costume. But back then when we were cavemen, we needed to be able to avoid danger, like, a falling rock or a tiger trying to eat us, or, I don't know, maybe we might find berries out there, and we quickly realize that it might be poisonous. So pattern recognition is super, super quick. It's the processing about what the extraneous information around that, which is, it takes a little bit more time. But even then, it's still very quick. And it's all done based off of just sugar and glucose. I am waiting for them to, because there's a lot of ghosts in the shell. Ghosts in the shell. That's all I'm missing. Ghosts in the shell. Whoever what's his name? The guy who made Ghost in the Shell, he was a prophet when it came to what's going to happen with the systems. Because that is exactly what's going to happen. Like down to a T, what he made in his dystopian Ghost in his story. It is, so far, everything seems to be following that route. But anyway, we'll look at that later. First, in a nutshell. Let's see here. We're here. Here. Oh, okay. I think it's because... All right. Let's see here. Let me load... I'm trying to get to the thing. Because my setup is a bit... Because my setup's a bit different. Would it be better to study all the wrong implementation? That's actually a very good question. That is a very, very good question, because all right, yeah, that's a very, very... part of me would say it would make sense to study the wrong implementations, but because of how the brain works, you can't... I feel like it would make more sense to study the correct way to do an implementation, or the better way to put it is to study how you want to get things done. And then when things ultimately mess up, as in the wrong stuff happens, you learn and correct. Yeah, that's, I think, the best way to do it, because that ultimately you're emphasizing the correct way of doing things, which is how you would want your brain to remember the information. This is the right way to do it, so let's do it this way. But by running into the roadblocks of messing up, it teaches your brain this is the wrong way to take. We need to do it a different way. The best way I can... Again, when I was a scientist, we did a lot of research with... I studied mostly zebrafish, because they have the ability to regenerate, which, while other creatures can... Yeah. When you're trying to study regeneration, you need to use the model that works. But the lab I worked in, there was another person who was using rodents as their test subjects, and they were trying to study actual learning in it. And what they would do is they would teach the mice to move a I don't know how you put a mouse on a pedestal, and you teach it to move a lever, and it has to move the lever in an L motion. So, okay, let me get GIMP back out. Oh boy, GIMP is getting used a lot today. All right then. So what you would do is you would take your little mouse here. Let's make our little mouse right here. So here's our mouse. And he's on a pedestal, like so. And here's his little feet. So here's one foot, and here's his other foot. And here's a lever. Now, the mouse is taught that if he wants to get a treat, in this case, it's chocolate milk. If you give the mouse chocolate milk, if he does the correct motion, they will learn very quickly. No. It's we'll get there. But it's important to explain that. But yeah, so what you'll do is you give the mouse chocolate milk if he does it correctly. Now the mouse needs to move this lever in an L shape like this. If he does it like a J, it's wrong. If he does it in a reverse L, it's wrong. If he just draws the line down, it's also wrong. So he needs to do an L motion. Down and then over. Like that. If he does, he gets rewarded And then you can start watching. Okay, in this case, in this case, you have what they did was they put a little glass in his skull so you could watch his brain. And he was a transgenic mouse, which means all of his neurons would light up. You would have a neuron. So here's a neuron right here. And when it fires, it'll get very, very, very bright. And then by doing so, you can then image neuronal activity while this mouse is doing his behavior. And for what they've learned in their paper, or they published on it, but what they've learned was that this motion here on the first day, it looks very much like this. The mouse is, we'll put the chart right here. The way it works is this is learning, and this is time. So down here, it means he doesn't know anything. Up here means he's learned a lot. And as the mouse learns, he does this kind of ladder motion like this. And you can see he slowly learns each day as he does the test. And the reason why is because all of the neurons are refining. You'll get this big explosion in activity, which will help him learn the movement. But then there's a pruning event that happens the day next. And this pruning overshoots. And because of that, he gets a bit worse. But then as he keeps practicing, he gets better because the neurons get more refined on what needs to be fired. But then again, more pruning happens, so he gets worse. And you end up, when you plot this graph out, you end up getting this sigmoidal of, if you standardize this, so this is the 0, this is improvement, this is loss. You get this weird curve like this, where effectively they become a master, where they become a master, where they can get finely tuned movements. So it's through repeated trainings across multiple days where they actively learn their, this L motion, and they're able to get their chocolate milk. All right. And yeah, this is how our brains work as well. So if you want to learn how to draw, don't worry about it being bad. Just put your hand to paper and then sleep on it. And then the next day, you'll find yourself have improved. And then at some points, you'll say, oh, my art got really well. Oh, my art looks really bad. Oh, it's great again. Oh, it's bad again. This is a natural progression on how your brain trains itself to become a master at a task. It's very fun. Okay, Brave. Let's connect to you. Open. There we go. Oh, actually, you know what? Then would it kind of reflex? Well, whoopsie. Oh yeah. Okay. The pressing the button. All right. Pressing the pad also changes. Okay. Well, it is kind of like muscle memory, but it's the brain. The brain is let's watch the video. It might help explain a bit. So let's watch the video, and I will stop here and there to try and chime in. Oh, and let me turn on the audio so you can hear it. It's a bit loud, so let me make sure that it's not too loud.
It's our biological magic that enable you to experience bygone moments over and over. With them, your mind can encode,
very loud, too loud.
about the world and yourself.
Okay, there we go.
But memories are not static like photos. Like dioramas made from wax, each time they're under the spotlight of your attention, your brain is just incorporating.
Yeah. Sorry. Okay.
What does it mean if they change? And more fundamentally,
okay.
What is a memory? How is a moment in time stored in squishy meat? Your brain. Okay,
I'm glad the audio is good. Okay. Your brain is, yes, this is very true.
Universe, so we need to simplify quite a bit. Scientific models work, but are not a perfect reflection of reality.
Yeah.
It's a bit like talking about elementary particles. But in a nutshell, what makes you think and feel is a complex system of about 86 billion neurons. Extremely
Yeah.
complex electrochemical root systems, sending and receiving signals through synapses, tiny gaps between cells where an electrical signal is converted into chemicals, bridges the distance, is received, and converted into electricity again.
All right. So let's stop for a second. Okay. So yeah, this is a basic rundown of how this works. As you can see here in their picture, you can see there's a whole bunch of neurons all connecting to each other, and they're interconnected. And they all, it's the different firing patterns which make up how your brain functions. Now, the thing is that if we're going to try and bring this to how AI, they said it was what, 80 billion neurons. We are trying to do things with 80 billion parameters. In fact, what was the latest one? Like 1 trillion parameters. So we do have the parameter, or we do have the, actually, one moment, let me think real quick. Let me think, because the parameters are something different. The point is that we are trying to get close to how these are connected, but we're missing out on a lot of the higher level stuff, which is what they'll get into. So
this is how neurons talk.
Let's continue.
And it's a busy conversation because a typical neuron is connected with up to 10,000 others.
Yeah.
Together, they're a network of hundreds of trillions of connections, 100 times more than galaxies in the observable universe. From these connections, the magic of your existence emerges. To create purpose in this chaos, some connections need to grow stronger. Whenever two neurons fire at the same time, their synapses change.
This is what I was talking about.
Get stronger. They become buddies if you want, and when their buddy calls, they join in. If we zoom out, patterns emerge. Dozens or thousands of neurons organize into local columns. These columns are very basic information processing units that process a tiny piece of all the input coming in from your senses, like dark and light, a location in space, how a texture feels, the sound of words, and so on. You have columns for sound, images, touch, etc., all located in different parts of your brain. These
Actually, I want to say it's not just the brain. It is not just the brain. For instance, if we go to the structure of the retina right here, the eye has the exact same stratification. As you can see, come on, let me see the picture. Yeah, this guy right here. If we zoom in, you can see this is the retina right here. And as you can see, we have the photoreceptors in the back right here at the bottom. These take in light. And then these connect all the way here to stratified right here with the horizontal cells, the bipolar cells, and the Mueller glia. All of these photoreceptors connect to multiples of these, and then they all communicate with each other, forming these kind of columns. Some of these, for instance, the horizontal cells, will acknowledge which photoreceptors fired and which photoreceptors did not fire, thus making it more precise, like precisioning on what the signal would be sending downstream. Same thing goes with the bipolar cells. It tells us which ones were on and which ones were off. And then the amacrine cells, they are also playing a role to say which retinal ganglion cells need to be firing based off of the signal up here. So you end up getting the similar stratified columns in the retina, like they just mentioned in the brain. And this, once it goes out of the optic nerve, it will head into the brain and it'll tell you a very precise details of what you saw. This is one reason why we have very clear, or at least, this is one reason why we can get some very good, clear vision. It's because of all of this pre-processing before it even enters the brain. Hey, Alex, Tab, how's it going? So this is So it's not just in the brain. It's also here in the eye as well. Very important. We are busy watching... okay, we're supposed to be learning Zig, but because we got distracted with... science, so we're now checking out a video from In a Nutshell before we get back to Zig. I know. Science. I know. I know. Okay, let's continue.
These columns are the gears of the biological machine that is your cortex.
Hey,
It's the fundamental hardware you emerge from.
science is too interesting.
Hear or feel causes the gears to move, which means your neurons to fire together. But for you to have a coherent experience,
Wait.
these
Oh.
gears
I want
need
to.
be
Oh.
connected.
I'm sorry. Maybe I should just let it go through first. This right here. You see this? They have a foot here, an ear, an eye. There's some hands. Like, you know, this is called a homunculus. Homunculus. Excuse me. Let's see here. Where are you? Yeah, here we go. Right here. This is known as the homunculus right here. You can, yeah, these you gotta love science sometimes. These are pretty much mappings to how or what part of the brains are the role that it plays. I need a drink. One sec. Oh, let me go get a drink. All right, I'm back. Okay, got a drink. My new BG homunculus. Yeah. All right, so the homunculus is supposed to be kind of a graphical representation. It was designed, I don't remember who exactly designed it, but the idea was because they discovered when poking around in the brain that different parts played very important roles in speech, in touch, in sensory stuff, and visual. So they ended up generating these different types of mappings to try and explain as a representation. For instance, right here, this guy is a representation of what we would look like if we followed the brain, pretty much, the details of the brain. As you can see, we have an awful lot of detail, or a lot of our brain is focused on the hands. And that's because our hands are a pivotal, they play a major, major role in how we interact with the world. So naturally, our brain will use a whole lot of it. And then likewise, our mouth, our lips, our face, all of this is also very large. And that's because we speak, we communicate. We use our tongue to interface with a lot of the environment. And we also have to pay a lot of attention to other humans around us, particularly their facial features and their facial expressions. So it makes sense that our brains would also have all of this. So it's just kind of fun that when you look here, they actually generate out their own little homunculi here, because here's the eye, which is a major part of the back of the head. If you ever hit the back of your head real hard, you might feel like your vision gets all messed up. That's because you're actually impacted the spot of your brain, which is where vision is processed. So it's fun. It's fun. Yeah. There's a lot of parts in the body that are just they call them the autonomic system. It pretty much means they function without the brain. They function without us having to cognitively think about it. This is actually one reason where the myth of 10% of the brain came from, because a lot of the brain is autonomic. So, yeah, because we couldn't poke it and get something to happen, we were like, oh, humans are only using 10% of the brain. But no, it's just because those parts of the brain are doing things that do not cause a muscle to move. All right.
Together, any moment you perceive is made from different parts, As you're watching this video, your eyes activate columns for vision and color in your visual cortex. Your ears transmit information to your auditory cortex. Language areas are decoding my words, while other networks keep track of your body and emotions. All these signals are processed in deeper areas of your brain that evaluate them, boosting what seems important right now and tuning out what doesn't. Vastly simplifying, this concert of all these different gears connected by levers, wheels, and screws comes together to create a new structure within your brain machine.
Oh, actually, to kind of mention, did you remember earlier we were just talking about that? He just mentioned it. Let's see here, right here, decoding. Well, the language areas are decoding the brain. Let's play it again.
All these signals are processed in deeper areas of your brain that evaluate them, boosting what seems important right now and tuning out.
And tuning out what doesn't. If you remember, I was commenting earlier on the tip of my tongue. Oh, I know this, but I can't think of it. And that's right here exactly. It's boosting what seems important at the given point and trying to inhibit what the brain thinks is not important. This is why you can have, you can be talking to someone and go, oh, I forgot where that place is. There's a very nice cake shop nearby. I just don't remember where it's located. And then 10 minutes later, after you leave your friend, you go, oh, I remember where the place is now. And it's because your brain is tuning out information that it thinks is the tuning out thing that I was talking about. The brain deemed that knowing where the cake shop wasn't important right now, even though you were talking about the cake shop. The brain does that sometimes.
What doesn't.
In the oh yeah, exactly.
Different gears connected by levers, wheels, and screws comes together to create a new structure within your brain machine. The assembly. A new pattern of synchronized activity within the grand architecture of your brain. This assembly of very different neurons firing together is what gives you the experience of being a human being in this moment. So the assembly active in your brain right now is you watching this video, hearing my voice, and learning about memories. But this is only activity without permanent substance. Like ripples on a pond, nothing will remain. Without memories, you'll be forever trapped in the present. To become a being that transcends time...
Oh, actually, I just want to comment. Did you know that we actually discovered a couple people? Okay, I wouldn't exactly say discovered. There were a couple people who had very, very unfortunate accidents. And yeah, very unfortunate accidents. And because of that, they lost their ability to form brand new memories. They had damage to an area called the hippocampus, which is responsible for memory formation. So they were able to retain everything they had learned. Come here, you. All right. Okay, I'm going to hold on to my dog for a second. He's being a nuisance. But yeah, there's some people who had, they had damage to their hippocampus, and they weren't able to form any new memories, but they still had the memories that they had formed before that. So they were still who they were, and they still had some recollection of, a lot of, they still had some recollection about the environment and such. But because they couldn't form new memories, not even new short-term memories, they would ask the same question 7-8 times within the span of 6 seconds because they just could not retain the information. They had to go into a home because they effectively couldn't keep care of themselves. They would ask you, what's for lunch? And then they would ask 6 seconds later, what's for lunch? We haven't had lunch yet, because their brains just couldn't produce a memory, even a short-term one. So here in the video, when they're talking about you just living a fleeting, living fleetingly in the moment, that is something. It is not a good point to be. This is not a good point to be when you can't even form a memory like that. I know. It is. Yeah, it's very bad, very bad. That's why I said. That's why I'm like, oh, I kind of feel bad for those people that happened to them. Oh, hey, Alec, hey, you might. I wonder. I don't think it's the person I'm talking about, because the one that I knew it was talking about had a complete, like couldn't even form the 7 seconds. But I do. There are. You're looking at another group where they were unable to form long term, or they were unable to form a certain level. Like, okay, without getting into too many details, there are 3 different sets of memories. There is immediate memory. Oh, are they still using these terms? Okay, I'm gonna explain it how I learned it. It might be different in modern terms now. I'll have to look it up later. But the way I learned it, there were 3 types of memory. There was immediate memory, there was short-term memory, and then there was long. Immediate is pretty much like immediate memory is you gain information, then you hold on to it for immediate use, and then you dump it. This is like that 7-second memory that that 7-second memory right there that we're talking about. This is great for when you're trying to do very quick tasks and you just need to briefly hold it. The short-term memory is where it's about 5 to 15 minutes long. And this is when you have to do tasks that are a bit longer, like, oh, I need to remember this phone number, or I need to remember this. I need to remember this phone number. I need to remember this detail. And then once I get it done, then I can dump it from my memory and forget about it. And then lastly is long-term, which is kind of what they're going through right now, what they're explaining right now. And all 3 of those function as a way to help you, function as a person. Ideally, the short-term memory will become a long-term memory if you keep using it enough. And the immediate memory, I think it just gets dumped. Don't quote me on that. Oh, what's wrong? What did you? I'm playing fetch with my dog, and I think he accidentally grabbed something. He grabbed something he shouldn't have. Are you okay? Oh, you silly dog. You okay? Will you please stop making noises in the microphone? Okay. But yeah. All right, why don't you lay down? Come on, lay down. We can play fetch later. Come on. Dogs. They're bothering me right now. It's just 5 o'clock and they're bothering so much. Lay down. I don't want you to hurt yourself again. So the amnesia, it's your brain losing... Let's see here. Let me highlight this real quick. Let's see here. Well, amnesia is a bit different. So, yeah, amnesia is a little bit different. When it comes to amnesia, think of it as your brain has it lost its ability to understand all of the neural firing that's going on in the brain. You have this is what I was talking about with the different layers. The layer, you have the neural firing pattern, and then layer 4 in the frontal cortex, which gives you the context. And when you have amnesia, that context is lost. Your brain forgets what the meaning that context meaning is. So your neurons would fire a particular path, but then you won't understand what it means, or you won't know the roadmap. And that's amnesia right there. Oh, let's get back to the video. All right, then.
You need to etch these fleeting sensory inputs, these temporary moments, into something physical that will remain. And how does your brain decide what becomes permanent? With a deadly competition. How to store the past. In reality, there's not just one assembly active in your brain. Your brain can't process everything in the outer and inner world with full attention, so different assemblies are fighting for dominance. The details are complicated, but at any moment, one assembly is winning and deemed the most important by your brain. This is what you're aware of right now. In your brain, the assembly processing the sentence I'm speaking to you seems to be the most active and wins. Your brain thinks this matters, and you're forming a new memory. Two things are happening right now. The neurons of the winning assembly are bathed in chemicals that make them more susceptible to change and tie them closer together, strengthening the synapses between them. And the memory center and librarian of your brain, the hippocampus...
Hey, we talked about him.
The details here are super complicated and the exact process isn't fully understood yet. But in a nutshell, your hippocampus creates a blueprint, saving the rough configuration of the assembly. The assembly is saved and put on an index with all your other memories that are associated with what was going on in this moment. Like every time I was confused by something in a Kurzgesagt video. Finally, you have a memory. An activation pattern of millions of neurons spanning many different regions of your brain. Activating any part of the pattern now makes the whole assembly fire. Now, you're able to relive a moment of the past that's gone forever in the real world. But this new memory is very fragile and still pretty temporary. Your hippocampus holds its blueprint, but without reinforcement, the assembly will fade and the synapses will be weakened again.
Guess. Well, as soon as I saw this part, guess what I said? And when in order for this, yes, hey, Buzzbird, Baldrin, how's it going? Yes, we are, learning about why I have trouble remembering all of the Zig stuff. Okay, then. But yeah, as soon as I saw this, the first thing I thought was, like sleeping. You need to rest in order to allow your brain to process what you've learned and strengthen those connections. So the first thing I thought was, you need sleep. And then let's continue and you'll see what it says.
Why you forget most moments of your life. Why you don't remember how your coffee tasted 43 weeks ago on a Monday. You experience most of your life only once in the moment you live it. And you don't just forget what happens to you, you also forget what happens in the world.
Oh, it's the ad. Okay.
Within days, and often you never even saw the full picture in the first place. This is why we've partnered with Ground News, a media literacy tool whose
why don't we skip ahead a bit?
Their app and website and directly supports our channel.
Ground News. Actually, I recommend Ground News. I use it quite a bit.
For the past to be truly saved, the assembly needs to fight for its life. There are many ways this can happen. One of them is novelty. If you walk to the bus, listening to some mildly interesting podcast as usual, this assembly's signal is too weak. This moment in time will be lost like tears in rain. But if one day you see a crow and a squirrel fighting over a nut, only for a mouse to steal it, the assembly will fire strongly just for the novelty of it all. Another one is to reactivate the memory over and over after it's formed. Thinking about the animal fight all day and telling everyone about the strange event will etch it deeper into your brain. Similar to doing loads of repetition when you try to learn something.
Actually, as you pass the part where... Oh, funny. But yeah, as I mentioned, this is actually one reason why it's fun to learn in groups, is because you'll be able to talk to more people about it. And through this conversation and discussing the stuff that you're learning, it will help strengthen those connections. This is actually one reason why I think it's crazy in a lot of schools where they go, now it's quiet time. Class, please, everyone shut up and go sit in your corner and learn by yourself. Like, no, people need to be talking about these things. You learn best in groups. The fun part in learning is to have conversations with people. So yeah, learning groups, that's one thing I could definitely recommend. And then the other one is novelty. Talk about this being a big problem for nowadays. I think there's an awful lot of people out there now who they're constantly doom scrolling to look for something new and novel, and they're just like hours and hours of their life are just being lost because their brain can't find that new novel thing. And it's such a short, immediate novel boost that, like, man, talk about a waste of a brain. Oh, I always love talking to people who are smarter than me. Actually, one thing that I've come to appreciate is that every person out there has their own experiences, which makes them kind of an expert in some particular fashion or field. I know it's not for everybody, but whenever I go out and talk to people, they all have some kind of knowledge that I never experienced. So it's always fun to talk to them, to learn about it. For instance, I know people who are into firing old medieval cannons. Oh, okay, not medieval. World War, no, the American Revolution. There, the American Revolution cannons. I know a lot of people who like to go out and fire American Revolution style cannons. I did not know this was a thing, and just listening to them talk about it and explain the details, like, yeah, they're the experts when it comes to that thing. But if they ever ask me about neuroscience, then hey, I can explain something to them. And it gets even funner when you find someone who's in like your own field, and then they can start explaining things that you didn't understand. Like, so it's fun. It's fun. I think the part that makes it uncomfortable is the part where, because there are some people out there who are, no, you calm down. No, I'm not going. No, I'm not playing with you. No, lay down. Lay down. My poodle. No, go lay down. Go lay down. He's trying to start playing fetch with me again, and I don't want him to yip again. I'll play with you later. Okay. He might start barking. Sorry if you hear a dog bark. But yeah, I think the part that makes it the most uncomfortable, I'm going to highlight this. I think the part that makes it the most uncomfortable is because sometimes the people who you're talking to who have a little bit more knowledge do not have a same level of humility, and thus they're, okay, for lack of words, they're a bleeding narcissist. And it's never fun. It's never comfortable to talk to a narcissist because they like to go, "Oh, you didn't know this. I thought that I knew this. I thought I knew it well. How could you not know something so simple?" Like, that's uncomfortable because like they're just being an asshole. But when you're talking to somebody who is humble and they just want to talk about the knowledge, it's the funnest thing in the world. Yeah, that's the problem. It's those narcissists who think they're smarter. Oh. Yeah, it's these who think they are smarter than you. They're not fun. That's very annoying. I agree there. 100. I agree there. But yeah, learn with friends. Let's continue.
A major way to make a memory stick is to feel emotions. Emotions are really strong mechanisms to guide our behavior that evolved hundreds of millions of years ago. They motivate you to avoid danger, seek out food, and reproduce. You experience this as something feeling good or bad. Whenever you feel something strongly, your ancient brain decides that whatever is going on is important for your survival, regardless if it's wrong or not. So many of your strongest memories have strong emotional flavors. The humiliation when you acted dumb in front of your crush. The joy when you beat your dad at Mario Kart. The devastation when your dog died. The overwhelming love when you held your first kid.
Let's see here. Not knowing about RFC 1149. Ah, yes. Those people, exactly. Yeah, those people. Oh. Actually, you know what? I wonder. Oh, I'm a bit too big there. We'll forget about that. Let's just get back to this. I've been setting things up on stream. Where I need to make the TV bigger. Okay. I'll fix that later. Anyway. Okay, let's continue with the video.
If we just made you feel something, we increase the chances that you'll remember this video. Strong activation, repetition, and emotions do the same thing to your memory. We said before that chemicals made the neurons able to change. Well, now they change drastically.
Oh, thank you, thank you.
Warming up and melting together, the gears of the assembly grow new teeth to fit more tightly. Neurons grow more synapses and fire together even better. They become closer and more solid. A lot of this happens while you sleep.
Hey!
The hippocampus replays the assembly over and over, making it more solid and easier to retrieve, which also means that if you don't sleep enough, you literally forget more of your life. Think about that when you have to study for a test next time. Without proper sleep, you'll be wasting your time. But
This is one reason why every time someone comes on stream and they say they ask about sleep, or they say I'm going to skip sleep today, I'm always like, no, don't do that. That's very bad. You're literally losing, like, your sleep is so important. It is like one of the most important things that our body needs is sleep. There have been studies. Should we go over that study? I guess we'll go over that study. All right. There have been studies where they try to prevent mice from going to sleep. The way they did this was they put them in a water trap where they have a little tiny pedestal. Okay, let me get this out so I can show you. Okay then. So let me draw this out real quick so I can explain it. Let me set a color. Why don't we'll just go with white for now. Okay then. So what they did was they took a basin. So here's a basin. It's pretty deep. And on it is a little tiny platform like this. And it's all filled with water. And in it, there's a mouse. He's a bit of a big mouse. So here's our mouse right here. Now, if the mouse is awake, he can balance himself on the little thing right here. And by doing so, he can stay dry. But if he falls asleep, he will fall into the water. And they would do this. They would do this test every. I think they did it like every 3 hours or something. It's just a 30-minute test to make sure that it would fully wake the mouse up. And they would do this. So every 3 hours, the mouse would do this test. And they did this for 2 weeks to see what would happen if you had maximum sleep deprivation. And yeah, they wanted to see what would happen to the health of the mouse if this happened. And let's just say that it wasn't very pretty. They had cognitive decline. So, brain go down. They ended up becoming hypertension, which means blood pressure goes up. They also had a lot of problems. In fact, these mice died. This experiment resulted in them not surviving, which is not a very, poor mice, but yeah, it was just to show, like, sleep, very, 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 very important. Like, super important. So, yeah, when you decide you're going to forget about sleeping for, like, I don't need to sleep anymore. What is this sleep you speak of? I will never do it again. Like, no, do not do that. You need to sleep. It's not the same for everybody. You need to find out what it is for you. For some people, they just need to sleep 6 hours. For others, they need to sleep 10 hours. Find what you need. It's different for person to person. And this is largely because human genetics is such, there's such high variation. There's such high variation. It really depends person to person. I mean, some people, they need to be more active, they need to be more asleep during the light hours for their brain to function better than during the dark. So it really, I'm not playing with you. Go lay down. So it really depends. On average, this is where averages are. On average, it's around 7.5 hours. For some people, they just need 6. As I mentioned, for some they need 6. For others, they need 10. If you're very unlucky, you need 14 hours, like a cat. And if you're very lucky, you only need 4 hours. However, I think the people who only get 4 hours, they have other complications. I would have to look more into that. But yeah, mainly, the main way to figure it out is rather than going to sleep and waking up by the clock, when you're tired, go to sleep. And then when you wake up, just see how long it took you to wake up naturally. And I don't mean like, oh, I want to roll around and continue laying on the bed. No, I mean when your brain is active and you open your eyes and go, I can get up now. Actually get up and then calculate how long it is. You'll find that it'll be roughly around 7.5. Sometimes it's 0. Yeah. The cramming sessions, they do help out a lot. You can definitely get a good... I hate tests. I hate how colleges are run. I really do. An article about cyborg... Oh, that I will have to check. Alex Tabitha. Alex Tabitha. I will have to check that out. That sounds awesome. I want to see what I'm going to have to check that out. Schedule time in and time out work for you? Hey, if it works, it works. I guess the main thing is just get the sleep. Are the 1.5 hour cycles of sleep true? I'm going to have to look that up. When you say 1.5 hour cycles, do you mean people who just only sleep for 1.5 hours? Let's see here. I'm going to look that up real quick. How much? How? I guess it might be this one, right? Oh, all right. No, that's something different. How just 1.5 hours can damage your heart. Okay. The about 90-minute REM cycles. Okay. It might be. I've seen people talk about lots of things. For instance, I saw someone say, there's a lot of people who try to go, we're going to maximize our schedule. We're going to sleep an hour, 30 minutes every hour and a half. So 30 minutes sleep, then an hour and a half. 30 minutes sleep, then an hour and a half. And that way you can maximize all your time. And like that doesn't sound very healthy. To sleep multiple. Oh, actually, I just described exactly what you're about to comment on. It depends. I would have to look more into it. I do know that elderly, for instance, when you hit the age of like 70, 80, they actually do what you're talking about, which is these 1.5 hour or, these very short sleeps. This is one reason why you typically find your grandparents napping midday, or, they have lunch and then go to sleep, or they have, then they watch TV and then they nap for 30 minutes, an hour afterwards. Like that's just kind of their cycle. And that's usually a cycle that's taken by the body because it's trying to conserve energy. And you tend to lose REM sleep doing it like this. REM sleep is very important. It is involved in the REM sleep is actually where memory formation occurs. And that's lost when you have very short sleep cycles. I'm trying to remember exactly. But if memory serves, you need the longer sleep cycles in order to enter REM sleep. So if you're going to bed and sleeping for 7.5 hours, then you'll enter REM sleep much easier, which will help with memory consolidation, brain repair, muscle and brain repair and such. But if you do these very short sleeps, it might help you with being functional, but you lose out on that deep sleep that you need. So I did not mean waking up. Oh yeah. The 6 or 7. I see. Is it 6 or 7 point? Again, that depends largely on you. That depends very, very much on you. It's because for me, I just need 7 hours. But whoops. Oh, yeah, I hit the button. I think we were around here. Okay. Yeah, for me, I just need 7 hours. For my wife, she needs about 7.5 to 8 hours. I have a friend down the road. He sleeps for he only needs about 6 hours of sleep to be fully functional and have perfectly fine. And then I know a person in the U.S. They have to sleep for like 10 hours. If they don't get 10 hours, they get bags under their eyes. It's crazy. So it really depends. Oh, my dog. Have you ever had a dog who just likes to be a nuisance? A big, giant nuisance who won't stop barking. You can hear him just grumbling now. Oh yeah, sleep is awesome. Sleep is awesome. Okay, let's get back to the video.
Making it more solid and easier to retrieve, which also means that if you don't sleep enough, you literally
thanks.
forget more of your
I had a lot of fun setting this up.
Think about that when you have to study for a test next time.
Yeah.
Without proper sleep, you'll be wasting your time. But in the end, you have a proper long-term memory. A diorama of hardened wax displaying a moment of your life. A scene etched into a pattern of connection inside your brain. Now, you can remember it forever.
Oh. Wow. Okay. We're about to get into something. This is a very fun point. The brain, remembering. They're going to get into this, but remembering is not like saving to a hard drive and then loading a picture back up. A lot of people tend to like to think that when you are, when you form a memory, you save it to a hard drive and then you'll just open it back up whenever you want to recall it. But that's actually not how it is. And they're going to get to that in this point. And it's very important, especially, it's very, very important. And I think that, we can get into more of the details about it once we see this. But I think that when you learn about this part and you try and take it to heart, it can actually change your outlook on life. So let's go through this part and I'll explain it as we get into it. The Mind Palace? I don't think we're talking about the Mind Palace. I think what we're talking about is the fact that memories are malleable. Your memory is not it's not solid. It is a amorphous blob that can change based off of how you're feeling and how you recall it.
Changes your memories forever.
Yeah, here it is.
To remember, you need a cue for the memory, something that's part of the original assembly. A smell, sound, word, or maybe the image of an angry crow. Your hippocampus searches its index for the cue, hopefully finding the right stored assembly.
This is where amnesia we were talking about.
Your past experience is retrieved. The diorama appears in your mind, and you relive seeing the crow and squirrel fighting. So far, so good. But as the diorama plays for you, you start changing it. Recalling memories is not like loading a video and pressing play. Under the light of your attention, parts of the wax become soft again, moldable, which means that as you experience the memory in your mind, the neurons involved are bathed in chemicals that make them able to change their structure again. Your hippocampus organizes memories based on a few things, but most importantly, the context of the experience. And the context is now very different. When you formed the memory, you were tired, in a mildly bad mood before work, and very surprised. Right now, you're putting the memory as you're having a night out with your friends and are telling your hilarious story of the epic squirrel-crow fight. and this new context seeps into the memory. New connections form, some synapses are weakened, while others reconfigure. The diorama changes, becomes funnier and more absurd. Not because you wanted to, your brain is just incorporating the new context of your life into the memory.
Like that is awesome, isn't it? The active part, actively remembering something changes your memory of it based off of your current context. So if you're happy, or if you're, for instance, if you're feeling happy about something and then you remember something, it will make the memory happier. If you're very sad and you remember something, it'll make the memory more sad. This is very this is a how to describe this? Like, this is very important to understand, because this, what it effectively means is that based off of your outlook on life, it can drastically impact how you view your past. So in other words, if you are a very pessimistic person who's always feeling like down, like, oh, if you're like Martin from Hitchhiker's Guide to the Galaxy, and you keep recalling all of your memories, even if you like won the lottery and you're Martin, you'll be like, oh, I won the lottery. It was the worst day of my life. Like, oh, I don't know, my dog, he accidentally hurt himself when he was playing with a toy when I won the lottery. Oh, he's so bad. It was the worst thing possible. Like, your emotions affect your memories. And it's very important. I think that more people need to learn this, because it can really put a context on their past, and it can really help you with your past.
As you finish your story, the light of your
We'll get to that in a second.
moves on. The diorama hardens again, now in a new form. The next time you remember the animal fight, you'll remember it as way funnier than when you actually experienced it. And it's the same with all your memories. When you retrieve them, your brain adds new information or forgets some, and incorporates your emotions and expectations. In a sense, it updates your past life to fit the narrative of your present life. Your brain...
Sorry.
To remember, you need
I need to
memory.
change that.
As you finish your story,
Okay.
the light of your attention moves on. The diorama hardens again.
The controls for my avatar also happens to change the playback on the YouTube video, so I need to make sure I'm not touching the same window.
Experienced it. And it's the same with all your memories. When you retrieve them, your brain adds new information or forgets some, and incorporates your emotions and expectations. In a sense, it updates your past life to fit the narrative of your present life. Over time, even core memories can shift, combine with others, or generate entirely new elements. Your memory system is deeply intertwined with the mechanisms for learning. It was never designed to create an accurate representation of the world. So your memories are updated as you gain new experiences and
I like the part when they mentioned
Ironically,
learning.
The more you remember something actively, the less of the original experience remains. This also means that just because you remember something really well, it doesn't mean your memory is correct.
Actually, this is one reason why, a bit of a tangent, but this is actually one reason why a lot of court cases and a lot of trials that require witnesses to recall an incident, why that these are technically are not considered they're considered valuable when it comes to a case, but they can't be definitive or definitive evidence, because their memories will change. In fact, just by putting a picture in front of somebody and asking them, was this the person you saw when the person ran out of the house? You actually could potentially be changing their memory to make it look like the person. It's a very, so it's the brain is a very interesting organ. Focusing. Yeah, you're, hey, boredom. Yeah. When you only focus on the negative, it can really impact your views of your past and make it more negative. Yeah, I know somebody who is depressed right now, actively depressed. And then when I keep talking to them, trying to help them remember the fun times of the past, man, the way that they view their past is, it's actually quite depressing, because you'll talk to them and they'll say, oh, my childhood sucked. I never did X, Y, or Z. And I'm sitting there thinking, but you did do X, Y, and Z. I was there. I remember that. I remember how happy you were. And now you're saying that you don't even remember that, or X, Y, and Z didn't matter. Like, it's very, yeah, it can be quite depressing when seeing that happen. This is one reason why I always think, I think that therapy, going to see to a psychiatrist, is actually very, very important. Oh yeah, I agree. I need to get back to journaling. I don't tend to journal much. I probably should do that. Actually, I wonder, I think they mentioned it. Let's continue the video. I think they actually mention it. We're almost to the end. Let's continue.
It just means that its assembly is really strong and vivid. It's not a sudden process. Your identity is safe for today. Your brain is...
Yeah.
Remember, you need it for learning.
Okay.
It was never designed to create an
okay.
representation of the world. So your memories are updated as you gain new experiences and information. Ironically, the more you remember something actively, the less of the original
nope, calm down.
remains.
Come on. I'll play with you in a sec.
Because you remember something really well, it doesn't mean your memory is correct. It just means its assembly is really strong.
My leg is going to be... Don't stop that. My leg is going to be all scratched up. My dog keeps bothering me.
It's a slow shift in the overall patterns inside your mind. You are who you are today, but your future self will be different, and they'll think and feel differently about the things you experience today. This is also why therapy can be so helpful.
Hey, they mention it.
Revisiting hurtful memories in a safe context, ideally with helpful introspection, you are literally changing your brain, literally rewiring yourself to get a chance to be happier. Because yes, your memories may be the law of your life and the basis for your future, but it turns out with some help, you may be able to rewrite your law and be who you want to be.
Okay, it was right at the end.
And if you want to rewrite the law of your home, new human-made original art prints just landed in the Kurzgesagt shop.
So,
a dramatic meteor shower, a tranquil lunar dreamscape.
Oh, hey. Those
eruption,
are...
Or even better, all of them.
Yeah, I should probably... I think I'm going to get back to... writing. The problem with me is that No, don't bark. The problem with me is that I want to write everything down. So when you look at my journals, they tend to be, rather than just like a paragraph here or there to explain what happened, I tend to go into extreme detail, like... Oh, actually, yeah, let's do that. No. Stop barking. Oh, my dogs. Let's change the audio. Here it is. Track 2. Okay. Okay, then. The music is great. Okay, yeah. So, I try to do writing, but I always try to overdo it when it comes to describing things. So, one of the journals I found, it was like 6 pages long, and I described down to how I was cooking how I cooked my breakfast, and what I ended up was trying to work on, and all of the problems that I was having. I mean, it's great in detail, but oh boy, it was it took more time to write up the report, write up the journal, than it actually took to recall it. So I ended up, I'm going to have to try and simplify the creation of these things, because I would like to keep a journal. Okay, you have a good one, Giovanni. Laters. Yeah. I'm gonna have to definitely see about my journal. Set up a journal. Problem is I tend. The problem is I tend to have a rather good memory. Yeah, I tend to have a very. I wouldn't say it's a perfect memory, but I tend to remember things a lot better than most of the people around me. So that also might be another reason why I tend to. I put way too much details into my journals, because if I just wrote it how I would remember it, I would look at it and go, yeah, I remember this. And for me, it's all about the extra details that I don't remember that I want to keep track of. You know, this is an awesome, this would be like an awesome background, just to be playing in the, like a wallpaper or something. All right, are you good? Are you good, Mr. Dog? All right, I think. All right, why don't you lay down? Come on, lay down. Lay down. Don't lick me. Lay down. Okay. All right. All right. Let's get back to Zig now. Let's get back to Zig. We got distracted. We had what was that? I think it was like, what, a 30-minute distraction from programming? Okay, let's hop on in here and translate this. So here it is. So Zig translate C. Let's head to our location. It should be included. And then let's go grab our M units. Oh, actually, let's do a quick check. Let's open up a new window. And let's see if we can get our path. So oh, okay, so that's not here. Includes. All right, I call it includes. Got it. Okay. All right, back to our programming. Includes, and then it should be, yep, M unit. And then this should contain our, there it is, munit.h. There we go. Now then, so from here, we then want to LC. Do not CRT stdio inline equal what? What does that be? Notice that this bash command, we are passing the necessary compiler flags. D to define the macros, L to link the libraries, and I to add the included path to compile and use this header file. Also notice that we are saving the results of the translation process to a Zig module called c.zig. Ah, I see. Therefore, after running this command, we will have to do this. All we have to do is import this czig module and start calling the C functions that you want to call from. For example, this is how we would do it. So const C, this is what I would like to set up like that. However, they saved it to the c.zig. We don't want to do that. It looks like this is the location they save it to. Let's see here. That's capital I. Instead of saving as a user, I'm going to go ahead and actually, yeah, I'm going to still send it to includes. We'll send it to here. And then lastly, do not cd no crt. What is that stdio inline equal 1 mean? The problem is that it has stdio in it. Or stdio, I guess is the better. Stdio is the better way to put it. Do not no crt stdio. Yeah, standard IO. Oh, actually, that would be much better. That would be much better to describe it as standard IO, because the other way it makes it sound, with biology as my background, saying it the other way makes it sound like something dirty. So standard IO. So I guess we'll put that there. Actually, question. If we go down here, I'm just doing a quick peek to see. I don't think we need that, do we? Yeah, I don't think we need that one. I'm just going to get rid of that. I get rid of that. Let's just send this to. This is going to be mutils dot zig. Hey, it's running. Hey, it's running. Okay. All right, let's let it run. Come on, buddy. Come on. I actually want to keep hold of this info. I know what I'm going to do. I'm going to print this. We're going to save this as a PDF. We're going to save this as a PDF and put it in a note section. We'll call this will be in the documents, and we'll call this the Zig materials. There we go. Save. Okay. All right. Okay. Good, good. Now let's go here. Hey, we have mutils.zig. Let's check this out. You know what? You know what? I'm very curious now. I want to grab the stuff from Boot.Dev and run it through this and see if it works. How about this? How about this? I'm going to go through Boot.Dev. I'm going to go through and continue working on building it out. That way it can help with some of my brain. And then what we'll do is we'll then run it through this as well and see if we can... All right, so let's go ahead and quit. Let's see. Oh, here we go. CD Boot.Dev. Let's see, what's our lesson right here? This happens to be lesson 14, so L14. And then let's go make some of these files. So let's go ahead and grab you. And then next one will be exercise.h. Exercise.c. And oh, this is just empty. I don't think I need to do that one. We're going to do it anyway. There we go. Okay, so now we have all of those. Now let's run it. Let's see here. Zig. Translate. C. Let's now get to our... let's see here. Let's get to our folder. There we go. So now we're here, and we want to get the exercise dot. It's actually they actually did the header. I wonder if we can. I wonder if I can just run this through here, and it will translate it. I'm gonna try. Main.c. All right then, and then next on the list is, oh, let's see here. They have LC and then I. Okay then, so LC, I. And in this case, I ended up doing home MPA includes. In this case, we're going to call this main.zig. Cache check failed. Okay, so yeah, I don't think I will be able to do that, which is understandable, I guess. I mean, it's not a header file, so it's very obvious, but you never know until you try. I should probably put the music back on. There we go. There we go. Now it's not quiet. Now we have at least some background noise. Okay, with that in mind, that means what we just need to do is to start doing our translation ourselves. Which is expected. So let's head over there. Oh, there it is. How are you finding it? Oh, I'm enjoying NeoVim quite a bit. I think NeoVim, I like there's a lot that I like about it, and there's a lot that I would, I have to get used to. For instance, I like the fact that I can have everything in a single location. Actually, I need to get back to using the, because I think it's what, shift I think that I can open up the tree. Okay, maybe not shift. Okay, there is a button combination. I don't remember the combination, but I can use it to start navigating within NeoVim instead of having to constantly exit and enter. I don't remember what it is though, but I'm enjoying NeoVim quite a lot. I like the it took a little bit of getting used to, but I like that the buttons are like I can use J, K, L, and H to move up and down the tree, or sorry, the lines. But you can use EX. Oh, I did. Oh, hey. Ah, okay. Let's do that again. Fun, fun. I will remember that. Thanks. Oh, that is... You know what I'm going to do? I am going to try and get my neurons to fire. I'm going to put this in the notes. EX. Allow to... All right, there we go. Aha, okay. I see, I see. I will have to... Oh, yeah. I think that I'm going to first learn the basics, and then once I get done with it, then I can start really diving in. Oh, I'll have to Control D and Control U. I will have to try that. Okay, let's see here. I've watched the Primogen programming before, and man, he makes using NeoVim. It's like a wizard. It's amazing how much how fast he goes between his all the stuff. Actually, I haven't watched him recently, so I don't know if he still does it that way, but I remember when I did watch him code, he was very quick. You learned it all from him. Yeah, he's surprisingly entertaining to learn from, so I enjoy watching his stuff. Let's see. Okay, so why don't we just go ahead and start putting these in. So... Actually, we just did a... if I recall, we just did a... can I import... Let's try. Oops. So it's going to be a const m units is going to be equal to importer. And then this is going to be m units. Is it .zig? Or quick question, how did they do theirs? Yeah, they did c.zig. I remember that. All right then. So if I do that, error. How much do you bet there's an error because of... Oh. Okay, I wonder if that's... I'm very tempted to see... I wonder if that is all we need to do. To be fair, though, these functions here, we're not really calling them. So I think I need to do that, right? Scrolling half pages. Oh. Actually, that would be very useful, half page scrolling. One of the most annoying things with when I'm going through like a normal document is page up and page down. They just jump too quickly. Actually, I think it's like G, isn't it? Like G12? Oh. Or is it 12G? Let's see here. 5G. Yeah, 5GG. 9GG. 12GG. 45GG. Aha! I like that. I see. GG is down and Shift G is up. Oh, yes, I remember. You're right. I remember going through that. I kind of forgot briefly about the Shift G, but I remember the GG. That'll be... All right, then. Let's see. So now I've imported in... Let's see. Can I put it right here? Or... I'm very, very curious. Okay, let's fix this first. This is going to be a const results. This is going to be a float. So this will be an F32. I think I was setting it up. I was setting up down here. And then this right here is double certs. Let's go ahead and fix the other ones too. So const f or const results f32. Actually, you know what? You know what? It looks like oh, they call result 2 and result 3. Okay, of course. All right, then. And there's an error here. It might be because of the... Oh. So I don't know what templates you're using, but if you see an error like E, Control W, and then D should open the error. Oh, that's actually very... I'm using the out of the box. I think that's the best way to describe it. I'm using the out of the box. I didn't change anything. And that's largely because I tend to not. Hey, Control W, and then I'm going to copy that. Aha, you don't mind me. I'm just going to Control W and then D. We'll open the error and give a description. There we go. All right, then. Oh, yeah, and we should probably put... There you go. We'll put this up here at the top. All right, let's go ahead and save that so that I don't lose the information. You should be at the notes. Yeah, right here, the Zig materials. No, or actually, this is NeoVim stuff. So, NeoVim notes. Oh. Up here, thank you very much. There we go. Okay. So Control W E. So let's do that again. Control W E. Oh, D. Oops. Control W D. Control W D. Expected comma after this field. All right. I think it might be because of the... But this M unit case... Hey, IU. How's it going? What we're doing is we're trying to learn Zig in the most awkward way possible. Because I need a refresher on C+ programming, so I figured I should go through Boot.Dev. Because Boot.Dev has classes. So check it out. They have classes on how to learn C. So I figured, hey, let's go through this. But because I want to learn Zig, what I have to do is I have to take their lessons that they have on Boot.Dev and translate it to Zig before I can start actively doing their tests. For instance, here they said that they are going to set up a file layout for doing your assignment. Here is their main function, where if you call submit or run, then it will run these for you. But because this is all C++, it's very different from Zig, which means I have to go in here and start modifying them here. And that's what I'm currently trying to do, is convert this C code into this Zig code. And then after we do that, then I can actually do the assignment and see if I can actually produce what they want me to do. It is a very silly roundabout way of learning Zig, but it actually helps you learn a lot because it teaches me about the differences between C and Zig and proper syntaxing in Zig. So it's not dumb, but yeah, there's probably a better way to do this. Let's see. Why Zig? That is a very good question. That is a very, very good question. Why did I choose Zig? I think I chose Zig because I had there's actually no real reason for me to have picked Zig. Maybe it's because I like the way that they do their syntax. I like the idea of defining out the like here importer and such. It reminds me a lot of other operate or programming languages that I did. No, I understand. It's just that it could have been Rust, or I could have just went with C++. I just decided to give myself a challenge of doing Zig because ultimately what I want to do is program because right now the way my avatar works is we generate movies. I mean, it looks pretty seamless right now because I've been putting in an awful lot of effort to generate these. So these are all individual movies. Let me show you, let me hop up here and so I can show you. So there we go. There's my avatar right there. You can see he's on a green screen. And if I turn off let me turn this off. There you go. You can see it's a video just constantly running of him chatting. Now, because of that, I'm doing a lot of silly little voodoo in the background to, hide the constantly running video when I am not talking. And when I talk, it will display the video for me. But because of this, it is, it's not very memory efficient. And given that I have a ton of videos and I have a ton of because every emotion is its own set of videos. So I have lots of different emotions. And actually, I think I had to do a lot of drawing to do this. But anyway, you get the idea. So what I want to do is I want to build a program which will take all of the pictures that I have. Let me load it up, right? Let me show you what I mean exactly. So if we go here, we'll go to happy. So here you can see all of the different parts. I have arms, I have the body, eyes, mouth. These are all individual components. If we go into eyes, or let's go into something that we can actually look at, VR eyes. So if we go into VR eyes, you can, okay, maybe not this one. Let's pick, let's actually go with I forgot, it's going to show up on a alpha. So here are the eyes. Actually, I haven't generated them yet, but I did actually make animations so my character doesn't have to have the VR headset on if I want to. But then here you can see here are all of the eyes, and there's the animation. And I have this for all of the different parts. So for instance, here's the tail, and here's the animation for the tail. These are all individual components. And yes, I'm doing it manually, which is why sometimes things mess up. I attached it to the numpad so that, for instance, if I hit 5, then he'll look this way. If I hit 4, he'll look that way. 2 is down, like, oh, I'm sad. And, 8 is up. And I can even go, hey, arms up, like happy, arms down, or, play a game. I have done a lot. So, and these are all individual pictures. So for instance, if we go in the body, we'll go into the hoodie and you can see here, like different body parts and how they're structured. And what I did was I wrote a program in Python. Here it is. The first one, what it does is it converts that layering format that I have. Because if you notice, each folder was its own layer. And I convert it all to a frame by frame. So I run this code. And what it does is it takes this data and converts it into this. So now each individual frame contains all of the different components. So now if I go through, you can see all of the different pieces. The arms and the body are considered variants. This way I can program it so that I don't have to... I wrote it in a bit so that it makes it a bit easier. And then here we have configs, which will just define which is a dynamic, which is static, what the overlay sequence is. For instance, if I wanted to put the tail at the very front or whatnot. And then these are modifiers. So if I wanted to, I don't know, make the eyes a different color, or I decided I want to change the entire body to be purple, I can then put in the modifier and it will do it for me. And then finally, all of the frames, each individual. So this animation has 12 frames, which is the idle animation. And then finally the layer config, which tells me, how many padding I will have. For instance, how many images before or after before we actually do the animation. The size of the image, the frame rate, and then here's the modifiers that I was talking about. In this case, I'm cropping all of the frames to because I found out that if I do any post-processing in OBS, it will completely bork the processor. So I have to do all of the processing before it gets into OBS. So this is where I put in the cropping. So I'm cutting it down to the size I want here. And with all that done, I can then just simply hop back into Python, run my animator code here. I can simply say the outfits, how I want to change the variations, run the code, and it will generate all of my videos. And then from there, it will be all formatted. I can just dump it straight into my... I can then dump it straight into the OBS, or into the OBS code. And this is how I end up having it so that I can, I can have a lab coat or my hoodie or, because it's the 4th of July. So a casual American flag t-shirt. Happy 4th of July, by the way. I'm American, so I'm going to, I'm American, so I figured I should at least show that, happy 4th of July. But yeah, let's see here. You're trying to learn Rust. It's like Python, but in C. Haha. Actually, maybe I should move over to Rust then. This is actually one reason why I chose Zig, was because it reminded me a lot of Python, but it was in a C++. Yeah. So maybe I'll check out... To be fair, the reason why I've been avoiding using Rust is kind of out of spite rather than because of any tangible reason. I've had so many people try to breathe down my neck about how grand and fantastic and perfect Rust is that I'm like, I'm just going to not learn it just to spite you. But I know it's kind of stupid. I should probably just learn it anyway because it's fun to learn, and it's a different language, so it's good to probably pick it up. Maybe I'll check out Rust. I mean, if they wouldn't, if the people wouldn't be so, again, if they wouldn't act the way they would probably have a lot more people interested in learning it. I always found that enthusiasm is a better way of teaching and better way of getting people interested than trying to shame people. Because I've heard people say, "Oh, you're going to learn C? Well, your code's not going to be secure. You're just going to make something full of vulnerabilities. That code's going to suck." Like, yeah, congratulations. You're not selling it. But the people who are writing Zig, they're like, check this out. This is so awesome. We're able to do this now. And check this out. We're able to do that now. And we're now trying to implement this. Like, it builds such it's so motivational. Like, hey, I should learn Zig because they make it sound fun. They're not trying to shame me to do it, to learn it. So yeah, once I get out of the holding a bit of spite, I'll go pick up Rust. I'll go learn it. I see. Yeah, I understand what you mean. Yeah. I feel that actually maybe I should just bite the bullet and just go ahead and start learning C. Uh, if you're, I am a expat. I am an American living in Hong Kong. I plan to make an outfit for my character, which is Hong Kong themed because yeah, I live in Hong Kong. Born in the States, moved so frequently that I moved so much when I was a kid that I tend to just say the U.S. is my place of origin. I I wish. I wish I was a trader. I wish I had. I wish I was earning. I earned through stocks, but yeah, sadly, no. I moved to Hong Kong because I met my wife, and she's Hong Kong native, so I moved to where she is. You went there when you're like 7 for yeah. Oh, the Disneyland here is fun. It has so many fun rides that you don't have in other places. And usually it's not very crowded. Okay, I don't want to say I don't want to say that because I haven't been there in a while. Oh, my dog's going to start bothering again. I haven't been there in a while, but when the few times I went to Disneyland in Hong Kong, it was great. Very fun. Lots to look at. Lots to do. And the lines, they were not long at all. So I got to check out a lot of stuff. I would highly, if anyone is interested in visiting a city, I would definitely recommend Hong Kong. Hong Kong has all sorts of stuff. My dog is being a nuisance. He's asking for pets, so I'm giving him pets, and he is wandering in circles, being a nuisance. All right. Yeah, if you ever get a chance to visit Hong Kong, I would definitely recommend it. Nope. No, be quiet. No, be quiet. No, lay down. Let's see, Hong Kong. It is a massive city. I will have to visit India when I get a chance. I will have to visit India when I get a chance because there are a couple places in India that I really do want to go visit. Let's see, are there any good pictures that I can find here in the actually, you know what? It might just be better to go to maps. Let's see here, where are we? Hey, there we go, Hong Kong. Okay. Yeah, there's a lot of great spots to visit here in Hong Kong. Let's head down here. This area here is called Shim Cha Shui. And this is on the harbor. And if you go here, you can go to a place called Avenue of the Stars. And this is pretty much a walkway across. Just look at the photo. Look at that. Look at how nice the view is. And check it out. You can see the light show during the night. Sadly, no. I don't know Chinese. Yeah, sadly, I don't know Chinese, but Hong Kong is considered trilingual. And what that means is that the natives understand English, Cantonese, and Mandarin. Okay, technically, it's called bilingual. Is bilingual +1, where they know Cantonese and Mandarin, and English is taught, so they have a general understanding of English. And because of that, I generally can communicate with people without having to actually learn Cantonese. Though I'm trying to learn it myself anyway, because, it's probably better to just learn the native language so I can communicate better. Yeah, they know English very well. A lot of people are very fluent here in English. Okay, can I see stuff, please? There is stuff here I want to show. Let's see here. 3 months, da 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 da. We're looking for reviews. But yeah, you can see here, look at the, this is what the harbor looks like at night. Look at the view. It's such a nice view. It is very nice. Oh yeah, and it's a lot of the good places to eat. A lot of the really delicious, tasty places to eat. They only serve menus in Chinese, so you either get someone who knows the language, or you spend an awful lot of time with Google Translate trying to communicate. It's much easier just to learn the language, hence why I'm trying to learn it. Let's see here. Okay, I'm trying to find... let's see here. I'm trying to find... Actually, I think it'd be easier if I zoom in here. K11 Museum. There's the McDowell statue. We're not looking for McDowell. Here he is. Yeah, here he is, right here. Check it out. A Bruce Lee statue. Oh, this is a good picture. Bruce Lee is a very famous actor from Hong Kong. If you, most likely, you might have seen his movies. Like, he is super famous. And they enacted a statue of him right here. So if you want, you can take photos with him. And I think everyone's done photos. Again, if we check it out, you'll see, like, it's the go-to to pose with. Okay, come on. Where are the people posing? There we go. There we go. See, there's a person posing right here. Aha, yeah. There we go. There's one person. There's another one. Nice. Oh, here's a lot of... Oh, here's someone who's trying to combat him. Oh, yeah. A epic battle between random guy and Bruce Lee. Who will win? Oh, it's going to be Bruce Lee, obviously. Like, you cannot defeat Bruce Lee. Let's see here. Awful lot of pictures of just the statue. I'm actually, to be fair, I'm actually looking for my photo. I actually uploaded a photo in here, so I was looking for mine. But I have a feeling I'm not going to see it. Okay, how about we do a quick fast scroll. There it is, there it is. I saw it. Aha, here you go. Here's my photo. There you go. Here's my photo of me posing with Bruce Lee. I know it's a face drop, so don't tell anybody, okay? Anyway, okay. Yeah. I just outed myself. People know what I really look like. On par with Michael... let's see. Oh, there's a lot of very, very famous celebrities that I think everyone knows about. Even the later generations now. For instance, Freddie Mercury. Who doesn't know Freddie Mercury from Queen? Or Michael Jackson, the king of pop. Bruce Lee. Jackie Chan. Like, some of these people, like, man. And even there's Michael Jordan. Even in the sports section, Michael Jordan and such. Like, some of these people are very, very influential. Or it just might be me showing my age. Because these were the people that I grew up with. All right. Anyway, let's get back to this. So, yeah. So this is what the Python code does. I ended up writing up a lot of different functions here. Like, this is parsing out the images and putting them in frames. This is importing in the data. I was trying to write it to originally have two different structures, but yeah, I couldn't figure out how to do a particular, like, how I would set up the config files for the layer format, which is why I wrote a code to convert the layer to a frame. And then finally, I did write some code here, which is the generator. Right here, it's a video generator. But the idea is that these would allow me to output a video or a stream of images. Now, if I could, because originally I was going to write my code for compiling the images and then outputting it to a video buffer. I was originally going to do it in Python. But then I quickly found out that CV2, which is the tool that I'm using for... CV2 is the tool that I was using for interfacing with, creating the videos and generating and modifying the images. Yeah, it's actually a bit slow when you run it through Python. I think it might be Python, but it's very, very slow. And something that I was hoping to get around 30 frames per second, I was getting 2 frames, 3 frames. And it was just, because of that, I couldn't get it to efficiently run through Python. I chose to write the code like this so that it would work in to generate the movies so I can have something. And that's why I'm learning Zig, is so that I can then create a file that will combine all the photos quickly and stream the photos into a video buffer, and then I can just generate all of these on the fly. So that's the general trajectory of the project. Hopefully I can get that way. That's the idea, at least. But this is also why I'm currently learning Zig, is because I need to first understand the basics before I can start getting into it. I did try to use Cursor, making your own language. Oh, that's. Hey, Lloyd, that will be a lot. That would be a ludicrously amount. I was very tempted to learn, because I wanted to make it as fast as possible. And it's dangerous. It's very, if you watch the Primeagen and you watch the 4 of them, what do they call the thing right now? It's when you have the 4 on there. You have Casey, you have Primeagen, you have Trash, and JT, or I think that's all 4 of them. Is those 4. When you have those 4 talking about it, especially when they start talking about optimizations, it makes you go, oh, you're right, I should learn assembly. And then I have to quickly remind myself, learning assembly, I'm already having difficulty stepping back from Python and learning C++. Yeah, I enjoy watching his stuff a lot. It's very fun to watch him talk about programming and such. Actually, I think it was him and a recommendation from a viewer to try out Cursor. So I was actually trying to get Cursor to generate something for me to build off of. I told it to write code in, I think I told it to write code in Zig, didn't I? Oh no, I told it to write in C++. Okay. So this was so I did tell it to write in C++. So I told it to write something in C++ to try and do what I want. And then here it tried to do a lot of changes. Let's see, can it actually, yeah, and then I ran into this here. You've reached your limit. And like, well, okay, thank you very much for reaching the limit. Because of this, I can effectively I only got to ask it 2 questions, and now I don't get to play with cursor anymore. And apparently doesn't update. I'm a bit surprised. I thought they would have like monthly limits. I was waiting for a month to see, but yeah, apparently I have to upgrade to Pro if I want to continue using their system. But yeah, they have generated I had cursor generate code. Let's go over to there. Oh, I want to go out. Then it should be here. It should be layer compositor. Yeah, so here is the code that it generated. Oh. So yeah, here's the code that Cursor generated for me. And then here we can see all of the different things, like they included the frame buffer. Here are the algorithms and a C string, png.h. And then here are the program or the different functions that they wrote. Actually, since we've been going through trying to learn Zig, the since I was trying to learn Zig, I've been picking up a lot of, so this is actually less foreign now. For instance, oh, I know what they're doing here. I know what's doing here now. I don't know why they wrote it this way. Like frame buffer, : clear. Maybe it's to put it into frame buffer or this. Or they're maybe overwriting it. I agree. They're very fun. They're very fun to watch. Yeah, and then here you have the frame buffer and yada, yada, yada. And then from here, and then here you can see they're including all the things. There's the microphone input, the layer configurer, the stuff that I asked it to write, and then here's more of their stuff that they generated. So it did generate a bunch of stuff for me. As I mentioned, I need to learn a bit about C to understand it, which is why I was learning Zig, ironically. But then, yeah, it does a lot of weird things. For instance, let's see here. Where's an example of what I'm talking about? For instance, this right here, the arg parsing. Like, I guess that, let's see. Yeah, that, like the arg parsing. The idea is that it's all going to be streamed. So the idea of having costume, emotion, window, like all this is actually going to, the costumes and the emotions, all this is going to be built in. And then I'll just be cycling through the different ones. So I don't know why we're arg parsing these. And then, let's see here. I don't know why we're doing a C out of this. I guess it's to do an explanation. I need to learn more. That's the main thing. Okay, anyway, let's get out of this. All right. Actually, it's 6:40 on my end. Actually, looking at the time, I think I need to hop off. You went to grab a coffee. It sounds like... no, I'm still tired. If arg equals string. Yeah. The it's done a couple things which don't make sense to me. So I need to this is also one reason why I want I was hoping to use that as a reference for, maybe that's a bad idea, trying to use it as a reference to learn. Hence why I went to Boot.Dev. I'll need to figure out more. But anyway, I've been streaming for about 3 hours. I need to hop off. It's 6:40 on my end. I need to start thinking about dinner. But it's been fun. It's been fun. I will continue programming. I'll continue figuring this stuff out. Oh, you don't think? All right, I'll have to figure it out. Anyway, you guys have a good one. Thanks for hanging out, and I'll see you guys later. And good luck with learning the code. I will continue at it later. Anyway, laters. Actually, before I hop off, I actually set up. My dog is barking. I actually set this up here because I was going to have my own little lab to show things off. But now that I've actually started streaming, I found out that the TV is a bit too small. It needs to be bigger. I'm going to have to fix that. Anyway, have a good one.